This is part 6 of our video on solving polynomial equations. So we are in the middle of solving by factoring, and we are on our very last example, which is example D. So I have 15x cubed plus 50x squared plus 2 equals 7x squared plus 7x plus 5. So when I'm trying to choose a solving method, the first thing I notice is that I can't just rearrange because I have 4 different terms that have x's, and they're not all like terms, right? I have x cubes, I have x squareds, and I have just x's. So rearranging works really well when you have one variable, or if you have a couple of variables, but they're all like terms that you could collect together. So that one's out. If I want to solve by quadratic formula or factoring, we always want it to equal 0. And this currently does not equal 0. So what I would suggest doing is moving all of your terms to one side. Now, whether you move them to the left or the right is up to you. I usually look for the one that has the highest exponent, which would be this one here, the 15x cubed. If this is positive, I will leave it on its side and move everything else over. If it's negative, then I'll take it all over to the other side because I like that leading coefficient, right? The very first term, the number in front of that first term to be positive. That's kind of just a personal preference. So I'm going to leave the 15x cubed on this side, and I'm going to move everything from the right side over. So I'm going to move the 7x squared by subtracting 7x squared from both sides. I'm going to move the 7x by subtracting 7x from both sides. I don't have a like term to write that next to, so I'm just going to put it up here. And then I'm going to subtract 5 from both sides to move that over. So I did try to put them next to the like term that they match up with. So I'm going to have 15x cubed. 50 take away 7 is 43x squared. And then minus 7x. And then 2 take away 5 is minus 3. And then on the other side of the equation, we took all of the terms away. So what's left? A 0. And it's really important for you to write the 0 there. We don't just stop writing anything. You have to show me that it equals 0, that there's nothing left on that side. Okay, so from here, I want to see what I can do. This has 4 terms. I cannot use quadratic formula on something with 4 terms. I could use it if it had 3 terms and it had the right exponents, but this has 4 terms, so there's no way. Now, when you have 4 terms, first thing you should always do is look for a common factor. 15 and 43, 7 and 3, they don't all have something in common, and they don't all have an x. So I cannot common factor this. Up next would be factoring by grouping in pairs. 43 and 15. Well, the things that go into 15 would be 15, 5, 3, and 1. And I don't really worry about the 1. 43 does not divide evenly by 3, or 5, or 15. So I can't even common factor anything other than an x squared out of there. So I would end up with 15x plus 43. Is this going to be 15x plus 43? No. So I can't factor by grouping. So then trinomial in 1, we have not used that, and this is not one of those questions. So that leaves me with, unfortunately, the factor theorem. So to do factor theorem, we look at all the possible factors that we could have, and then we test them until we find something that makes this equal 0. So for my possible factors, I usually take the factors of the last term and divide them by the factors of the first term. So my last term is negative 3. Things that divide into negative 3 would be 1 and 3. They could be positive or negative. Things that divide into my first term, that's 15. That would be 1 and 15. 2 does not divide evenly into 15. 3 and 5 make 15. 4 does not divide in evenly, and then I'd be up at 5, and that's the end of my list. So my possible factors that I want to check are going to be 1 divided by 1, which is 1, 1 divided by 15, which is 1 over 15, 1 divided by 3, and 1 divided by 5. And then I do the same thing with 3, so 3 divided by 1 is 3, 3 divided by 15. Now that actually reduces to 1/5, so you don't have to include it, but if you want to include it, you can. 3 divided by 3 is 1, so you could write 3 divided by 3, but you don't need to because it is technically already on the list, and then 3 divided by 5. So if you want to include all of those, that's great. If you want to say, well, 3 divided by 3 is 1, which is on my list, and 3 over 15 is on my list, you're welcome to just leave them out. Okay, so these numbers all could be positive or they could be negative, which means I have 2, 4, 6 times 2, so 12 numbers to work with. So I need to find one number that when I sub it into my equation gives me 0. All right, this just takes some work on our calculator. I'm looking at those numbers, and I'm seeing a 43. I don't think 1 is going to work because 15, 7, and 3 are not going to cancel out of 43. So I might try 3, and then if those don't work, I'm going to work on the fractions. So I'm going to try 3 first. So 15 times 3 to the power of 3 plus 43 times 3 squared minus 7 times 3 minus 3 equals not 0. So that means not a factor. All right, let's try negative 3. Okay, so 15 times negative 3 to the power of 3 plus 43 times negative 3 squared minus 7 times negative 3 minus 3 equals, ta-da, 0. Yay! That means I found a factor. So negative 3 is not actually the factor. Negative 3 is what I would get if I set the factor equal to 0. So what we do is we say that x equals negative 3 is the number that gave us a 0. And then I move that to the other side to get x plus 3, which is the factor. So what this means is that my equation here is going to be x plus 3 times something equals 0, right? So I know that one of those brackets, when this is factored, is going to be x plus 3. How do I find the rest of that expression? Long division. So I am going to divide x plus 3 into 15x cubed plus 43x squared minus 7x minus 3. Do that over here on the side. So how many times does x plus 3 go into 15x cubed plus 43x squared minus 7x minus 3. Now you should hopefully be able to do the division on your own. I'm going to work through it, but it would be great if you could try it on your own. So I'm going to do x into 15x cubed. So that would go in 15 and then x squared times. So 15x squared times x is 15x cubed. 15x squared times 3 is 45x squared. And then I subtract. 15 minus 15 is 0. 43 take away 45 is negative 2x squared. And then negative 7x take away nothing is negative 7x. And negative 3 take away nothing is negative 3. How do I turn an x into a negative 2x squared? I multiply by negative 2 and x. So that gives me negative 2x squared when I multiply it by x, and then negative 6x when I multiply by 3. I subtract. Negative 2 minus negative 2 is 0. Negative 7 minus negative 6 is the same as negative 7 plus 6, which is negative 1x. And then negative 3 take away nothing is negative 3. How do I turn an x into a negative 1x? I would multiply by negative 1. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. I would subtract. Negative 1 minus negative 1 is 0. Negative 3 minus negative 3. That's negative 3 plus 3. That's also 0. And the remainder here should always be 0. And if it's not, we have done something wrong. So that means the missing bracket, when I factored, it's going to be x plus 3 times 15x squared minus 2x minus 1. Okay. So from here, I do need to just take a minute and see if I can factor 15x squared minus 2x minus 1 a little bit further. So I'm going to do that off to the side, just looking for a different color to use. And to move the page a little bit. All right, so I'm going to try to factor 15x squared minus 2x minus 1. So we are looking for two numbers that add to negative 2 and multiply to negative 15. Things that make 15 would be 1 and 15. I'm not going to get a 2 from that. 2 does not divide into 15. 3 and 5, I could do that if I had negative 5 and positive 3. That would multiply to negative 15 and add to negative 2. So this is going to be 15x squared minus 5x plus 3x minus 1. From the first pair, I can take out a 5 and an x. 15x squared divided by 5x is 3x. Negative 5x divided by 5x is minus 1. The second pair, 3x minus 1, I can take out a 1. If they don't have anything in common, I always take out a 1. 3x divided by 1 is 3x. Negative 1 divided by 1 is negative 1. So this is 3x take away 1. 5x plus 1. So I'm going to put that in place of that. So in its factored form, we have x plus 3, 3x minus 1, and 5x plus 1. And that still equals 0. So something people do, it's a common mistake, is they drop the 0. This is an equation we are trying to solve. You need to keep writing it. So now that it's in factored form, how do I find something that makes this 0? Well, as long as one of these brackets is 0, then the whole thing will become 0. So I'm going to look at what makes each one of these equal 0. So I always, when I'm doing the lesson, show my work of how I'm getting them. But if you can look at x plus 3 and know that that's negative 3, if you just want to write x equals negative 3, I'm okay with that. But I will, as part of the lesson, show the steps because there are some people who like the extra steps. 3x minus 1, what makes that equal 0? Well, I could add 1 to get 3x equals 1, and then divide by 3 to get x equals 1/3. Now, if you could look at that bracket and you knew that it was just x equals 1/3, you're welcome to just write x equals 1/3. All right, last one. What makes 5x plus 1 equal 0? I would subtract 1 to get 5x equals negative 1, and then divide by 5. So I have x equals negative 1/5. Same thing, if you could look at this and know that it's x equals negative 1/5, you can just write that. I don't have a problem with that. So I am just going to finish off with a little therefore. X could be negative 3, it could be 1/3, or it could be negative 1/5. Okay, so our homework for today, the extra practice, is in the textbook. Now you don't have your textbook yet, but I will post a scanned version of this lesson, of this page in Brightspace for you under today's folder, right? So you'll be able to find this page posted there. Okay, so that's the end of our lesson on solving polynomial equations. It was very long, but we made it to the end. So I will see you tomorrow for your test.